Hello, everyone. Welcome back to day 31 of Coding Every Day. Today is February 15th, 2025 at 2:27 p.m. So today is a very special episode because it's exactly 1 month since I started, so that's exciting. Right now I'm doing graph problems in this NeetCode roadmap. So I looked a little bit at this one, and I think I have an idea of how I want to solve it. So I'm just going to jump into one that I haven't thought about at all and haven't seen before. So hopefully we can get a little bit more problem solving for this episode. Okay, so it's called surrounded regions. We get a board of X and O's. If a continuous four-directionally connected group of O's is surrounded by X's, is it considered to be surrounded? Change all regions of all surrounded regions of O's to X's and do so in place. Okay, so let me first understand this part. So continuous four directionally connected group of O's. To be honest, I don't really know what that means. Does it have to be a square? Four directionally connected group of O's. Four directionally connected. Let me see if I can get another test case. No. So this one, okay, so essentially, if I could figure out what this means, I can go through each O and check if it is surrounded. If it is surrounded, I can change it to an X. Okay, so this one, this O, is not surrounded because there is no X to the right of it and no X to the left. This group is surrounded because every O is surrounded by an X or an O, I think. So like there's no part of this group. So if this tile right here was an O, then this group would not be surrounded because one of the O's. Okay. So let me draw this example here. So X, 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 O, 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 like this. So in this case, I think what you can do is label each O as a surrounded O or a non-surrounded O. So this is a non-surrounded O because to the right and to the left are not X's. This O is a surrounded O because it has a surrounded O. Okay, so an O is surrounded if it's surrounded only by X's or other surrounded O's. Okay, so if we introduce this here, then this is a not surrounded O, which makes this a not surrounded O because there exists something that is not an X or a surrounded O adjacent to it. So here has an X, so it's still surrounded. Here, we don't know if this O is surrounded or not. And here we don't know if this is surrounded or not. But here we know that it is not surrounded, so therefore this is not surrounded. So I'm wondering if we could approach this recursively. And so let's say we get an O. And this one, okay, we see it's not surrounded. So we label this as like not surrounded. This one, that's an X, that's an X. And then this one, we don't know its quality, if it's surrounded or not. So we then check like recursively, like we have a function called like is surrounded or something, and then we check if this one's surrounded. The only problem with that is we don't know if this is surrounded. So like we would say, so then when we explore this one, we need to know the condition of this one, which we don't know until we calculate this one. So, okay, that's interesting. Maybe a more simple way of looking at it would be because the only O's that can't be surrounded is if there's an O that leads to the edge in the group, or else it must be surrounded. So, like, in this case, none of these O's lead to an O that's at the edge. So, therefore, we know that all of them are surrounded. So, a trivial solution, I guess, would be you could, like, DFS from every O and see if you ever reach an edge, like like any O on the outer ring. And if you do reach it, then that one would be not surrounded, and if you do reach it, it would be surrounded. And yeah, instead of like the recursive thing I'm talking about, as soon as we figure out that something is surrounded, then we can just make it an X, which will make all of these searches more easy, because instead of like seeing if you're like, instead of making a distinction between surrounded O's and non-surrounded O's, you can just make it an X, which will simplify it a little bit. So then there's only O and X. So for instance, like if this is an O and we determine that it can't reach the edge, then we make it an X. And now when we do this one, we determine it can't reach the X now. It can't reach the edge. And then that would make this one. So like what I'm trying to say is that every time we do an O now, it gets easier because we have more X's. But okay, so if we do it like that, I'm just trying to think of like efficiency and stuff. So what if we consider okay, so we have all X's like that. Like this. Okay, so ideally in this case, if we want it to be the fastest, what we would do is check this one, and then this one would be instant. And then this one, and then this one would be instant. The worst case would be if you check like this one, because you have to check all of those, and then you check this one, you have to check all of those, and then this one, you check all of those. Like that. So that would be inefficient. Maybe there's like a trick we can do where so if we're looking to see if one O is surrounded or not, every O that we explore during that process also has to be surrounded as well. So we can think of it as like sort of like the island. It's sort of like the island problem where you have different islands. So here's like an island and here's another one. So if we determine that one part of this island is surrounded, then everything in the island has to be surrounded. It's not possible that, because, so if we have an O here, then that means this whole island is not surrounded. So essentially what I'm trying to say is every piece of land in the island has the exact same state, either surrounded or not. So what we could do is like, depth first search from this one and just keep track of everything that we have done. And then if it ends up being surrounded, we can turn all of those into surrounded. And if everything is not surrounded, so I think we'd have like a visited set. So in this case, let's say we start here and we DFS like here, here, here. And then we determine that this one is surrounded. Then we know that everything we visited is in surrounded. So we could maybe have a set called like this island or something, or like current island. The only problem with that is I'm pretty sure you can't determine if it's surrounded until you've traversed the whole island. And then once you know it's surrounded, you kind of have to go back through the whole island. But I guess that would just be like 2n and not really n squared. So that would be fine. So we'll have like a current island set, and then we'll have a visited set. And current island will get reset every time we traverse through a new island. And then visited will never reset. Okay, and I don't think breadth first search versus depth first search is important here. I think you can do either one. So I'll do DFS. That might actually be better. Like it might, well, okay, so another thing I just thought of, with if we do DFS for instance, and our island looks like this. Let's say we start here and we go like this. We've only explored these 3, but we have to make sure we turn all of these into X's. So only don't turn them into X's right when you find, oh wait. Actually, well, we wouldn't turn them into X's anyway. I guess my point is like, well, so I was going to say make sure that you turn them all into X's after the whole DFS has included, and not when you figure out that it's surrounded. But I think that will happen at the same time, because in order for you to figure out that it's surrounded, you will have had to explore every piece of the land. So I think that's actually fine. So you can just complete the DFS. So in the case of where it's surrounded, you'll complete the DFS and then turn all of everything you explored into an X. In the case that it's free, like this, let's say you start here, you'll know once you get here that this island is free. So you'll just complete the DFS and mark everything visited, but not change it to an X. Okay, so I think we have a good idea where to start. And then this one, okay, so in terms of code of like how I don't know if I should just say if you reach an O that's in the outer ring, or if I should say if you explore something that's out of bounds. I don't know I think that exploring something that's out of bounds would be kind of more elegant. Because if you're ever exploring something that's out of bounds, then you know that you're not surrounded. So we could just say if it's not bounded, then this island is free and not surrounded. So we'll do that. Okay, so we're given a grid. All right, and we're going to have to do this for every island. So I think what we'll do is say for I in range length of board, for j in range length board of 0. If ij not in visited, then we want to explore ij. So as we, and explore will just kind of be like DFS essentially. So we'll define a function called explore. And we're also going to need a function bounded. Okay, so explore will take in row and column as the starting point. So we'll make a stack with the tuple row column. And we'll say while stack row column equals stack.pop. And then we'll say for delta r delta c. So this is just a basic DFS here. So -1, 0 is to the left. Actually, same row, -1 column. Up is -1 row, same column. To the right is same row, 1 column, and then down is 1, 0. Add the commas there. Okay. And this should only contain O's. So if it's not bounded, so if not bounded, let me just write this function real quick. So here we want to return the Boolean condition. So the row has to be between those bounds and the column has to be between those bounds to be bounded, like that. Okay. So if it's not bounded, then this means whole region is not surrounded. So I think this is, we also probably want current island. And then visited should just be a set for every single island. So if it's not bounded, I'm not really sure what to do yet. If it is bounded, then we want to add it to the stack. So stack.append row column, no, new row, new column, and then visited.add new row, new column, and then current island as well, right? Let me just try this. Print explored so if it's not invisited and board of ij equals 0. Okay, let me see if this output file is too large. Really? Do I have an infinite loop somehow? Oh, we want to check if it's not an X as well. So if it's not bounded, and let's just say if board of new R, new C equals X, continue as well. I don't know if that'll fix it. Does it run if I get rid of the print? Okay, I guess I have an infinite loop somewhere. Oh, I'm not checking if it's invisited. That's right. If new R, new C, invisited. Okay, first check if it's bounded. And then this should work now. Okay, so here we explored 1, 1, 2, 1, 2, 2, 1, 1. Wait. 1, 1, row 2, column 1, row 2, column 2, row 1. Oh. This has to have a row column in it. And then we also want visited to have it as well. There we go. Okay. So 1, 1, 1, 1, 2, 1, 2, 2, 1, 2. All right. So after we explore one island, here we should say island finished. Yeah, that looks right. So here we explore the first island, and here we explore the second. So if it is surrounded, so I'm wondering if this should return something, like maybe a variable, like island surrounded is false. No, it's true. We assume it's true, and then if you encounter something that's not bounded, then we know this island is not surrounded. Okay, then what do we want to do? So if it is surrounded, so should we return? I think maybe we should make this function called is surrounded, or island. Okay, let's see what this does. Is surrounded is not defined. I probably have a typo. Oh, island surrounded. Perfect. So here we've identified this island as surrounded and this one as false. I'm curious to see. Okay, and then I'm thinking we also want to return current island. So we could return a tuple with surrounded and current island. Okay, and then we'll call another function. So I'm going to make another function called convert surrounded to x, which takes in island positions. Okay, so we're going to get if it is surrounded in island positions, and then we'll say convert island to X with island positions if surrounded. All right, so here island positions is a set of coordinates. So we'll say while island positions board of RC, and we should be able to just do it like that. Convert island to X is not defined. What do I have it called? Convert surrounded to X. I like convert island better. Okay, so that seems to be working. Let's see if I can error. Oh, that's it. Okay, let me look at the time complexity here. So it should be m times n, right? Yeah, m times n. And let's observe. Let's study the solution's time complexity and see if it's within the recommended here. Okay, so this part, I'm gonna move down here. All right, takes a surrounded island and converts all positions to X. Returns if position is within all right. Explore all unexplored O's and call converts to X's if region is surrounded. I'm just reversing some logic here just to make it less indent looking. Okay, determine if unexplored O is surrounded. If surrounded, convert entire region to X's. All right. All right, so we've cleaned it up a bit. DFS through region and determine if surrounded. Surrounded. Exploring unbounded region. Okay. And let me do this here. So if it equals x or new r visited. Okay, so runtime complexity. So this part obviously is m times n. And then for every m times n, well, it depends. Because if it's invisited, we do nothing. So if it's not visited, then we visit every other one in a depth first search. And this part, so in other words, we can look at this as this part is basically for every island. So we know a DFS, so it's tricky because this isn't really m times n, because every time we do a DFS, we are limiting the number of times that this does something because we are making things invisited. Okay, so if we assume the whole island was O's, that would be the worst case scenario in terms of runtime. So if the whole island was O's, then one DFS would, for every node, in the worst case, would do four directions. So it'd be 4 times m times n. And then once it would have to convert to x's, but I think this is like a 2n situation because it's not, there's no quadratic behaviors. It's basically like exploring everything and then doing something again. So that's like 2n, or like 2 times, it's like n plus the DFS time. So I think this would be classified as m times n, and then probably like times 4 because of the way every node has 4 edges. So yeah, I think it fits in the time complexity here. So yeah, I think that's pretty good. I guess I'll leave it there. Thanks for watching, everybody. So today was 1 month. I think I'm gonna do this one in my free time. It's actually very similar, I think, to the one I just did. And then after that, so a lot of these are kind of 2D array style. Course schedule. Okay, so this one doesn't give you an array. It gives you an adjacency list, which is basically every element in the list is a edge. So I'm looking forward to that. I think it's just a dependency graph. So yeah, all right. I'll leave that for tomorrow. So thank you guys very much for watching, and I'll see you all tomorrow.